Well, ladies and gentlemen, welcome back. So let's go ahead and finish up our business so that way we can put this behind us. At this point, I'm going to finish with problem number 6 from that part that we were wrapping up in class. And this is a little bit more ticklish than some of you may have thought. We need to be thinking about those trigonometric identities that we dealt with earlier. And the one that jumps out in my mind as I'm looking at this example is the sine of x over x. And you might say, well, that's a huge stretch. I agree. But if we think about it like this, okay, limit as x approaches 0, and we can certainly take a tangent away, tangent of x, of course, and then we still have another tangent of x, but that's the sine of x over the cosine of x divided by x. It may be wise to see it that way. And if you say, well, I'm not quite sure yet, I'm not sold on this, let's see why. Perhaps we could rewrite this as a limit as x approaches 0 for the tangent of x. And then division by x is the same thing as multiplication by the reciprocal. And so that would give you the sine of x over cosine of x times 1 over x. I think you see the light at the end of the tunnel now. So all of a sudden you have the limit as x approaches 0 for the tangent of x times 1 over the cosine of x. So this is like a dance. We're rearranging. And then we have the sine of x over x. Of course, we know that the limit of the tangent of x as x approaches 0 is 0. The limit of 1 over cosine of x as x approaches 0 is 1 over 1. And the limit of the sine of x over x as x approaches 0 is 1, as we learned today. So 0 times 1 times 1 is going to be 0, and we have the end of our journey and a correct answer for what is a relatively challenging limit. Now, the unit 1.7, okay, which we did not get a chance to talk about, I would like to highlight a couple things for you. For your, I guess to help you, there are some trig identities that I think you would want to go ahead and review and to take command of. And meanwhile, these are nothing but algebraic and trigonometric simplifications of problems that will then allow you to solve some of the problems that you will see in AP Classroom for Unit 1.7. So let's take a look at number 1, relatively tricky problem. We are looking at the limit as x approaches 3 for this particular expression. And we will excuse that. And so what we need to do is perhaps to take a look at the problem a little bit more closely. And I think we actually have a small typo here. Perhaps we can make this approach from the left. And now we have a good problem. Thank you for bearing with me on that. And so at this point, what we have here is the limit as x approaches 3 from the left. And we have, let's see, x minus 3 times x minus 3. And we have the cosine of x over. Now, if this is a left-hand limit, the absolute value of x minus 3 is going to be, of course, the opposite of x minus 3 whenever x is less than 3. And it's going to be x minus 3 whenever x is greater than or equal to 3. So in this case, because we're looking at the left-hand limit as x approaches 3 from the left, so consequently, we are going to use the definition up on top. And we remove the absolute value. And of course, we have the quantity, the negative of the quantity of x minus 3. And that leads to a simplification where we have the limit as x approaches 3. Let me fix that. As x approaches 3 from the left, and you have the negative of x minus 3, cosine of x. So the problem denominator has been removed, and this function can actually be evaluated by direct substitution, and we end up with, let's see, 3 minus 3 is 0. So this is the negative of, or the opposite of 0 times the cosine of 3, and I believe that that results in 0. So we have our limit, and so hopefully that was an easy solution for you utilizing the absolute value definition right here. We rewrote that as a piecewise defined expression. So continuing to scooch down to problem number 2, a different kind of problem, but you see immediately that if you take the limit of the denominator as x approaches 0, let's see, e to the x minus 1, that is indeed 1 minus 1 and 0. So we need to do some sort of algebraic transformation. And if we look at the numerator, it looks like we can actually factor that. It's a difference of squares. And so we have e to the x minus 1 and e to the x plus 1. All that over e to the x minus 1. And we can cancel out the common factors. And so we're talking about one of those functions where they are identical everywhere except at x equals 0. And so the original function is right here, and the function that behaves exactly the same way everywhere else except at x equals 0 is going to be, let's see, the limit as x approaches 0. So we cancel out the e to the x minus 1 factors, so that function that behaves the same way except at x equals 0 is 4 times the quantity of e to the x plus 1. So again, here we can identify this through direct substitution. And so we get, or find the limit through direct substitution. And so we end up with 4 times e to the 0 is 1. So 1 plus 1. And so 2 times 4, the limit is 8. So lots of algebraic manipulations here in this section. What we're striving to do is to remove that factor that is causing a problem for us, where the denominator is 0 when we approach it, when we attempt to take the limit of that denominator. Problem number 3. Again, if we find the limit as x approaches 3 for the denominator, we get 0. This is a problem. So we need to use some sort of algebraic manipulation. And I believe that the answer is to multiply by the conjugate of the numerator. So here we have a minus sign. And so we're going to multiply the numerator and the denominator by the square root of x plus 1 and then plus 2. But of course, you must deal with the denominator the same way. And when you do, in the numerator, we end up with the following. When you multiply this, you end up with x plus 1. And when you multiply here, we end up with, let's see, minus 4. In the denominator, I'm not going to actually multiply. Well, I will, but I'm not going to distribute. So we have the x minus 3 factor, and then we have the factors of radical x, well, the radical x plus 1 plus 2, that quantity there. And in the numerator, well, you're probably saying to yourself, okay, let's not get too fast. What happens to the middle term? Well, the answer is the middle terms cancel. So when you multiply this radical x plus 1 times 2, okay, and then when you multiply, perhaps, let me see how I can identify that. maybe we can highlight underneath here, when you multiply the -2 times the radical expression here, those will be additive inverses. They cancel. And so it's a busy field already. I did not record the the products. But what do we get? We get the limit as x approaches 3, and we have x minus 3 in the numerator. Oh, well, that's really nice. That's promising. We have that factor in the denominator as well. And that's why I urge you not to distribute the x minus 3 in the denominator. That would have only confounded the process. So at this point, the x minus 3's cancel. We have the limit as x approaches 3 for 1 over radical x plus 1 plus 2. And this we can actually evaluate by direct substitution, ending up with 1 over the square root of 4 plus 2. And so 1/4 is your answer. So lots of algebraic manipulations going on until we eliminate the factor in the denominator that causes this expression to have a 0 there. And so at this point in time, it is something we can evaluate. We are quickly marching on to our last example. This is a complex fraction. It's not easy to look at. The denominator is 0 when we find the limit, not acceptable. So let's see what sort of algebraic manipulations will help you. Of course, a blast from the past, what you want to do is look at this expression and strive to make it so that it's manipulated into something that is not a complex fraction. I have always been a fan of multiplying by the least common denominator for the numerator and denominator. And so what we end up with here is x plus 4 times 4. And let's see, this is going to be a nice factor to multiply by. The result is, of course, going to give you, let's see, the limit as x approaches 0. And we end up with a 4. And then, of course, a minus. We have to be careful. It's a minus the quantity of x plus 4. The distributive property could be your enemy. Let's hope not. And so in the denominator, we have 4 times x times the quantity of x plus 4. Now, the denominator we're hoping to cancel out is the x, because that is what's making the denominator 0. So let's see what we can do. If you distribute the negative sign here in the numerator, we end up with the limit as x approaches 0, and you have 4 minus x minus 4. That gives us a lot of hope, and let's see what happens. So we have limit as x approaches 0, the 4's cancel, we have negative x, all that over, let's see, 4x times x plus 4. And now you can see the x's cancel. They're common factors. This is the factor that was giving us grief early on. And so at this point, I think we are very close to a solution. What do we see? We can solve this by direct substitution. And I see negative 1 over 4 times 4. And that is negative 1 over 16 as our final solution to this limit. Folks, thank you for giving me a little bit of your time. Hopefully this helps you out, and looking forward to seeing you at our next live session. Thank you.